So now if you have to represent compound inequality on a number line, how do you do it? So let me take you through step by step. So step 1 is to make sure that the inequality is written in the simplest form. So what I mean by simplest form, it is to make sure that x is isolated. Okay? So for example, you have to change this into this. And you'll do so by solving, which is what we have learned from the previous parts of the video. Then, step 2 is to identify the lower bound and the upper bound. So what do I mean by that is, if you take this for example, the lower bound will mean the smaller number, and the upper bound, it is the 2. And for the last few steps, it is to first determine if it is an open or a closed dot. And remember, from here, open dot is when your sign has no line below, and a closed dot is when it is inclusive and has a line below. So, subsequently, you represent your number line just like this. So, this is an example of the end compound inequality. This is a representation of the or compound inequality. So, let's look at the end first. Remember, step 1 is to isolate the x. So, after isolating the x using the mirror rule, then you will get this answer. And from what we learned just now, we are supposed to identify the lower bound and the upper bound. So the lower bound is 0 and the upper bound is 3. So, and since both signs do not have the line below, they are both open dots. And now that you have identified the position of the open dots, you then connect them, which will give you the number line. Moving on to the OR example, the OR compound inequality. If you have x greater than 1 and x greater than 5, how do you find the lower bound or the upper bound? If you ask, you just have to simply mark out where your 5 is, where your 1 is, and also see if it is an open or closed dot, and just draw the number line in the direction of the sign. So when you meet all compound inequalities, you first have to draw your normal number line as it is. Draw number line respectively. Okay, so you'll get two number lines like this. And then you just need to find out the overlapped areas over here. Okay, so number 2 will be doing overlapped areas. So for all compound inequalities, it is more special as your rules might tweak a little bit. So here is how you find it. Here is a neater representation of what I just talked about for the all compound inequality. So your first step, it is to understand the inequality. So if you have this, we know that x is smaller than 1 or x is greater than 5. So to identify the lower and upper bound, you just have to mark out where your 1 is and where your 5 is. And then, since both do not have the line below, they are both open dots. And just as previously mentioned, number 1 was to draw your number line respectively. So what I mean by that is because both are independent inequalities, so they do not meet and connect each other. Hence, for this one, you have to draw x smaller than 1 first. Then, you have to draw x greater than 5. And this will be your final number line. Unlike the previous one, where there are overlapped areas, there are actually two kinds of number lines you can draw for all compound inequalities. So please take note this and the previous slide's example.